we're going to look at process flow charting, and not very sophisticated charting, just some basic charting. But if you think back to the intro, we talked a lot about this thing called the process. In actuality, if you remember, that when we're talking about quality control, what we're talking about is monitoring a production process and looking at how that process functions. Actually, what we're monitoring is the variation present in the process, and every process has variation in it. It always happens a little bit differently. That variation can represent what we often call common variation, which means simply variation that comes out of the nature of the process. The way we've decided to do it is going to create a certain amount of variation. Assignable variation within a process represents that something's gone wrong. Something within the process is not happening the way we meant it to happen or designed it to happen, and we need to track that down and correct it. In those situations, when we're setting up a process or looking at a process, we have to thoroughly understand that process. In fact, many times, if we're going to work with other people, we have to make sure that if we're going to get some quality input from them, they have to thoroughly understand how the process functions. In many of these situations, a simple or basic flow chart is a good tool to use. In fact, it's a good tool for you to use to evaluate, do you really understand how a process works? Now, I'm not going to get carried away with this, but I want to just take a look at a simple flow chart of a process. I'm only going to use 5 symbols here. The oval will typically represent the start-stop symbol. Rectangle will indicate some action taking place. The diamond, which I obviously didn't draw very well, the diamond represents a decision, a conditional decision. If you think about it, it's kind of the if situation. If this is true, do this, otherwise do something else. The connector, sometimes we'll use a connector when we have a variety of flow lines coming in together into a central point. Instead of just having them all butt into each other or intersect each other, we'll put a connector in and they'll come into the connector. And then finally, flow arrows, lines that have arrowheads on them. And you'll notice that when we look at a little example here, some of them don't. You don't need to get carried away with the arrowheads, but you want to use them where you feel that there needs to be, person needs to fully understand or thoroughly understand where it's going. So what I've done is I've taken something as simple as calling a friend. And like I said, I've done it very simply, but let's take a look at the process. Now, what do we know about when we call somebody? There's a good possibility they may have an answering system of some type. They may not, but they very well may. So we might encounter that. So what I've done is I've said, here's where we start the process. It starts right here, and I'm going to dial the number. I didn't put in here, look up the number or get it out of your phone book or anything like that. You know, you can understand. So I'm going to dial the number, and now I come to a decision point. Does somebody or something answer? In other words, if there's a person there, I'm going to assume they would answer the phone. Or if they have a voice message system, it would answer for them. If neither of those happen, it would just continue to ring and ring and ring, and ultimately, when there is no answer, you are going to terminate the call. So you see the flow arrow says if there's no answer, we come down here and we move over here and we terminate the call. Now, one thing that you at this point should have noticed is there's one entry point and one exit point. Now, that's not always true of all processes. Sometimes there's multiple entries and multiple exits, but if you can limit it down to a single entry exit, sometimes it makes it a lot cleaner to see. On the other hand, if the phone is answered, and at this point I don't know whether it's answered by a person or by a machine. So the answer is yes, it's answered. So now I flow over here. Now you notice I didn't put arrowheads here or here. Actually, I should have put one here. Typically, we don't bother them when it's just a straight drop to the next procedure. It becomes superfluous to that. But over here, something's answered. So now I'm going to ask the question, who answered? Was it a person or was it a machine? I'm looking for a person. If a person answered it, then I'm going to talk to them. And after I'm done talking, I now terminate the call. If, on the other hand, it's not a person, and I forgot my no in here, it was a machine, now I have to decide, do I want to leave a message or not? If I choose to leave a message, I come over here, talk, in essence, give the message, and then terminate. If I choose not to leave a message, I come over to this guy and come in here and simply terminate the call. Now there's no point in here where we really need to use a connector, but to give you an example of how that might look, I could have used connectors here where these lines come together. Typically, we don't use a connector when it's just two lines coming together, but in some cases you'll have 3 or 4, and that's where you would use the connector. But at least this will give you an idea of where the connector would fall into that whole scenario. So like I said, if you're going to solve quality problems, you're going to have to fully understand the process that they're coming from. Right? And the best way to do that is to ask yourself, can I generate a picture of it? It's kind of like we looked at with the charts. The charts give you a picture of the data or the voice of the process. This gives us a picture of how that process operates.